Article 310.15b3 of the National Electrical Code, or NEC, addresses the ampacity adjustment requirements for conductors in raceways. When a raceway contains more than 3 current-carrying conductors, the ampacity of each conductor must be derated. This is to prevent overheating due to the cumulative heat generated by multiple conductors in close proximity. In this specific scenario, Romex conductors are run through a 2-inch conduit from the service entrance panel to the attic. Because there are several Romex conductors within this conduit, it is essential to determine if derating is required. To determine whether derating is necessary, firstly, identify the current carrying conductors within the conduit. Grounding and equipment grounding conductors are generally not considered current carrying conductors for derating purposes. Neutral conductors in a 3-wire circuit from a single-phase system are also typically not counted as current carrying conductors. Secondly, count the number of current carrying conductors. If the total number of current carrying conductors exceeds 3, derating is required according to NEC Article 310.15b3. Thirdly, refer to NEC Table 310.15 Con to determine the applicable derating factors. This table provides adjustment factors based on the number of current carrying conductors in the raceway. For example, if there are 4 to 6 current carrying conductors, the ampacity must be derated to 80% of its original value. For 7 to 9 conductors, it's derated to 70%, and so on. Fourthly, determine the initial ampacity of the Romex conductors. The ampacity of Romex conductors is typically based on the 60 degrees Celsius column of NEC Table 310.16, unless the terminations are specifically rated for higher temperatures. Fifthly, apply the derating factor to the initial ampacity. Multiply the initial ampacity by a derating factor obtained from NEC Table 310.15 Con. The result is the allowable ampacity of the conductors after derating. Sixthly, ensure the derated ampacity is sufficient for the intended load. The derated ampacity must be equal to or greater than the non-continuous load plus 125% of the continuous load. Continuous load is defined as a load that operates for 3 hours or more at a time. It's crucial to note that even if the conduit is short, the derating requirements still apply if the number of current carrying conductors exceeds 3. The length of the conduit does not negate the need for derating. Additionally, consider the ambient temperature. If the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, an additional ampacity correction factor may be required, as specified in NEC Table 310.15b2. This correction factor further reduces the allowable ampacity of the conductors. Proper installation practices are also essential to ensure the safety and reliability of the electrical system. The conduit should be properly sized to accommodate the conductors, and the conductors should be installed without damage to their insulation. Using appropriately sized bushings at the end of the conduit protects the conductors from abrasion. Furthermore, all connections must be made properly, and the equipment must be properly grounded. Ignoring derating requirements can lead to several potential problems. Overheating of conductors can damage the insulation, leading to short circuits, ground faults, and potentially electrical fires. Overloaded circuits can also cause breakers to trip frequently, disrupting power supply. Therefore, it is crucial to comply with all applicable NEC requirements to ensure the safety and reliability of the electrical system. In summary, when running several Romex conductors through a 2-inch conduit from the service entrance panel to the attic, derating is required if the number of current carrying conductors exceeds 3. To determine the allowable ampacity after derating, follow these steps. Firstly, count the number of current carrying conductors. Secondly, refer to NEC Table 310.15 Con to determine the applicable derating factors. Thirdly, determine the initial ampacity of the Romex conductors based on the 60 degrees Celsius column of NEC Table 310.16, unless the terminations are rated for high temperatures. Fourthly, apply the derating factor to the initial ampacity. Fifthly, ensure the derated ampacity is sufficient for the intended load. Also, consider the ambient temperature and apply additional correction factors if necessary. By following these guidelines, you can ensure that your electrical installations comply with the NEC and provide a safe and reliable power supply. Remember to always consult with a qualified electrician or electrical inspector if you have any questions or concerns regarding electrical installations. They can provide expert guidance and ensure that your installations meet all applicable codes and standards. Let's delve deeper into the specifics of conductor derating according to the National Electrical Code. We'll explore how to accurately apply the derating factors and ensure your electrical installations are both safe and code compliant. Firstly, identifying current carrying conductors is crucial for accurate derating calculations. As mentioned earlier, grounding and equipment grounding conductors are generally not considered current carrying conductors for derating purposes. However, it's important to note that if a neutral conductor in a 3-wire circuit from a single-phase system carries only the unbalanced current from the line conductors, it is typically not counted as a current carrying conductor. However, if the majority of the load is nonlinear, such as with electronic devices, the neutral conductor can carry significant harmonic currents, in which case it must be counted as a current carrying conductor. Secondly, let's consider a scenario where you have 6 current carrying conductors in the 2-inch conduit. According to NEC Table 310.15 current, the derating factor for 4 to 6 current carrying conductors is 80%. This means that the ampacity of each conductor must be reduced to 80% of its original value. For example, if the Romex conductors are 12 American wire gauge or AUG and have an initial ampacity of 20 amps based on the 60°C column of NEC Table 310.16, the derated ampacity would be 20 amps multiplied by 0.80, which equals 16 amps. Therefore, after derating, each 12 AWG Romex conductor can only carry a maximum of 16 amps. Thirdly, it's essential to verify that the derated ampacity is sufficient for the intended load. The derated ampacity must be equal to or greater than the non-continuous load plus 125% of the continuous load. For instance, if a circuit has a non-continuous load of 10 amps and a continuous load of 5 amps, the required ampacity would be 10 amps plus 1.25 multiplied by 5 amps, which equals 16.25 amps. In this case, the derated ampacity of 16 amps for the 12 AWG Romex conductors would not be sufficient, and you would need to either reduce the load or use larger conductors with a higher initial ampacity. Fourthly, ambient temperature correction is another critical factor to consider. If the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, an additional ampacity correction factor is required, as specified in NEC Table 310.15 BTUR. For example, if the ambient temperature is 40 degrees Celsius and the conductor insulation is rated for 90 degrees Celsius, the correction factor would be 0.87. This means that the ampacity must be further reduced to 87% of its value after the initial derating. So, if the derated ampacity of the 12 AWG Romex conductor was 16 amps, the final ampacity after ambient temperature correction would be 16 amps multiplied by 0.87, which equals 13.92 amps. Therefore, in hot environments, the ampacity of conductors can be significantly reduced, and it's crucial to account for this in your calculations. Fifthly, proper installation practices play a vital role in ensuring the effectiveness of derating measures. The conduit should be properly sized to accommodate the conductors without overcrowding. Overcrowding can restrict air circulation and increase the temperature inside the conduit, negating the benefits of derating. The NEC specifies the maximum allowable fill for conduits, and it's important to adhere to these guidelines. Also, the conductors should be installed without damage to their insulation. Nicks, cuts, or abrasions in the insulation can create hot spots and increase the risk of electrical faults. Using appropriately sized bushings at the end of the conduit protects the conductors from abrasion as they enter and exit the conduit. Furthermore, all connections must be made properly using approved connectors and techniques. Loose or corroded connections can create resistance and generate heat, which can overload the conductors. The equipment must be properly grounded to provide a safe path for fault currents and minimize the risk of electrical shock. Sixthly, let's discuss some common misconceptions about conductor derating. One common misconception is that derating is not required for short conduit runs. However, the NEC requires derating regardless of the length of the conduit if the number of current-carrying conductors exceeds 3. The length of the conduit does not negate the need for derating. Another misconception is that using larger conductors eliminates the need for derating. While using larger conductors with a higher initial ampacity can help mitigate the effects of derating, it does not eliminate the requirement to derate if the number of current-carrying conductors exceeds 3. The ampacity of all conductors in the conduit must be derated according to NEC Table 310.15 Kern. Another misconception is that derating is only required for power conductors. However, derating applies to all current-carrying conductors, including control conductors and signal conductors. If these conductors are installed in the same conduit as power conductors, they must also be included in the derating calculations. In summary, conductor derating is a critical aspect of electrical installations that ensures the safety and reliability of the electrical system. By accurately applying the derating factors, accounting for ambient temperature, following proper installation practices, and avoiding common misconceptions, you can ensure that your electrical installations comply with the NEC and provide a safe and reliable power supply. Remember to always consult with a qualified electrician or electrical inspector if you have any questions or concerns regarding electrical installations. They can provide expert guidance and ensure that your installations meet all applicable codes and standards. Understanding the practical application of these derating principles can further solidify your knowledge. Let's walk through a comprehensive example. Imagine you're installing 612 AWG-THHN copper conductors within a 1-inch PVC conduit running from a service panel to a subpanel in an attic space. The attic's ambient temperature can reach up to 45 degrees Celsius during the summer months. Firstly, identify the conductors. All 6 conductors are current carrying. Secondly, determine the initial ampacity. According to NEC Table 310.16, 12 AWG-THHN copper conductors have an ampacity of 30 amps at 30 degrees Celsius. Thirdly, apply the derating factor for the number of conductors. With 6 current-carrying conductors, the derating factor from NEC Table 310.15 current is 80%. Therefore, the ampacity after conductor derating is 30 amps multiplied by 0.80 equaling 24 amps. Fourthly, correct for ambient temperature. Since the ambient temperature is 45 degrees Celsius, you need to apply a correction factor from NEC Table 310.15b2. For THHN conductors rated for 90 degrees Celsius, the correction factor at 45 degrees Celsius is approximately 0.91. Therefore, the ampacity after ambient temperature correction is 24 amps multiplied by 0.91, resulting in approximately 21.8 amps. Fifthly, determine if the derated ampacity is sufficient for the load. Suppose the subpanel feeds a combination of lighting and receptacle circuits with a total non-continuous load of 15 amps and a continuous load of 5 amps. The required ampacity is 15 amps plus 1.25 multiplied by 5 amps, totaling 21.25 amps. Since the derated ampacity of 21.8 amps is greater than the required ampacity of 21.25 amps, the 12 AWG-THHN conductors are adequate for this application, considering both conductor derating and ambient temperature correction. Sixthly, verify the conduit fill. Ensure that the 1-inch PVC conduit is appropriately sized for 612 AWG-THHN conductors. Refer to NEC Chapter 9, Table 1 for conduit fill requirements. If the conduit is overfilled, it can lead to overheating and potential damage to the conductors. Seventhly, inspect the installation. Double check that all connections are properly tightened and that the conductors are free from damage. Also, ensure that the conduit is adequately supported and protected from physical damage. By meticulously following these steps, you can ensure that the electrical installation is both safe and code compliant, accounting for conductor derating, ambient temperature correction, conduit fill, and proper installation practices. Let's also address some advanced considerations. Firstly, harmonic currents can significantly impact conductor derating, particularly in circuits serving nonlinear loads such as LED lighting, variable frequency drives, or electronic equipment. Harmonic currents can cause the neutral conductor to carry a substantial amount of current, even in balanced three-wire circuits. In such cases, the neutral conductor must be counted as a current-carrying conductor when determining derating factors. Secondly, the type of conductor insulation affects its ability to withstand high temperatures. Conductors with higher temperature ratings, such as THHN or XHHW, can operate at higher ampacities and are less susceptible to derating due to ambient temperature. Always choose conductors with appropriate temperature ratings for the intended application and operating environment. Thirdly, consider using cable management techniques to improve air circulation and reduce the overall temperature within the conduit. Bundling conductors tightly together can restrict airflow and increase heat buildup. Using cable ties or spacers to separate conductors can improve air circulation and reduce the need for excessive derating. Fourthly, in some cases, it may be more cost-effective to install multiple smaller conduits rather than one large conduit with heavily derated conductors. Splitting the conductors into multiple conduits can reduce the number of current-carrying conductors in each conduit, thereby minimizing the need for derating. Fifthly, always consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Electrical codes can vary depending on the jurisdiction, and the local inspector can provide valuable guidance and clarification. By considering these advanced considerations, you can optimize your electrical installations for safety, efficiency, and compliance. Remember that conductor derating is not just a theoretical exercise but a practical necessity for ensuring the long-term reliability and safety of electrical systems. To summarize, let's recap the key points of conductor derating. Firstly, conductor derating is required when the number of current-carrying conductors in a raceway exceeds 3. Secondly, the derating factors are specified in NEC Table 310.15 cone. Thirdly, the derated ampacity must be sufficient for the intended load, including both non-continuous and continuous loads. Fourthly, ambient temperature correction is required when the ambient temperature exceeds 30 degrees Celsius. Fifthly, proper installation practices, including conduit fill and conductor support, are essential for effective derating. Sixthly, harmonic currents can significantly impact conductor derating in circuits serving nonlinear loads. Seventhly, consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. By adhering to these guidelines, you can ensure that your electrical installations are both safe and code compliant. This detailed explanation provides a thorough understanding of conductor derating, enabling you to confidently apply these principles in various electrical installations. Always prioritize safety and consult with professionals when in doubt.